Okay, so Mr. Kleiber has given you a sequence chain, and let's give a title to this because we are summarizing what we have learned the last couple of days, which is the substitution method. Just like you have a substitute today, and this is the substitution method. Get it? I knew you would. Okay, so first of all, we are given a problem. We are given 3n plus 5m equals 7 and m minus 4n equals 6. Our first step will be to isolate one of the variables. Now, it doesn't matter which one. Isolate the variable. It doesn't matter which one you choose, but you want to pick one that's kind of easy, right? So when I look at these two equations, I can look at the n here or the m here or the n. Well, my winner is going to be that m. So let's get it by itself. So I'm going to add 4n to both sides. So I get m equals 4n plus 6. So now I have isolated the variable. So now what I do is I'm going to substitute that expression into the other equation. So I'm going to substitute into other equation. And this is why we call it the substitution method. Okay? Okay. So I am going to replace m with 4n plus 6. So 3n plus 5 times a quantity of 4n plus 6 is equal to 7. Fantastic. We have now substituted m into the equation, so you'll notice now in this third equation I've written, there's only one variable now. It's an n and an n, and we can solve this. So of course then that would be our last step. Not last, I'm sorry, don't get too excited. So now what we are going to do is we are going to solve the third equation. Solve the third equation. Okay. Now using our properties of equality, first we'll do the distributive property. So 3n plus 20n plus 30 is equal to 7. Combine like terms. So, whoa, 5 times 6. Wait, 5 times 4n. Oh, yeah, that's right. So now I combine like terms, so I get 23n plus 30 equals 7. I'm going to subtract 30 from both sides. So 23n equals negative 23. And now I'll divide by 23. So n equals negative 1. Woohoo! I found one of the solutions. Now it's time to find the other. Now I have a choice again to make. Choices are great. And I get to decide, do I want to place this n equals 1? Do I want to place it into this equation here, or this equation here? They're all part of the problem. Well, this one looks the simplest to me, so that's what I'm going to do. Okay? So we're going to substitute, again, the substitution method, substitute the value into an equation. Again, you can pick any of them, but pick easy, right, folks? Right. Okay, give myself some space here. So I'll use a different color. So negative 1 is going to go back into one of the original equations. I need to see the original equations. Okay. So it's, how about if I go m equals 4 times negative 1 plus 6. So m will equal negative 4 plus 6. M is equal to 2. Woohoo! I now have the solution. But before I'm done, I must check, because these values should make both equations true. So over here I'm going to do my check, and so, okay, woo, I had a little mental breakdown. So now I'm going to replace n with negative 1 and replace m with 2, and we're going to see if this works. So I get negative 3 plus 10, yes, 7 equals 7. Now we can't stop because we got to check the second equation. So m, which is 2, minus 4 times n, which is negative 1, is supposed to equal 6. 2 plus 4 equals 6. Yes, I am now done. Please don't stop. Okay, now I'll go back to. Well, here we are now for today's lesson. We are going to learn another method for solving a system of equations. And this time it's called the addition method. So what I'd like you to do on your piece of paper is make sure you put the title, the addition method, and then put today's date, and then we'll begin. So I'm going to have Mr. Kleiber pause the video now while you get ready. Great. Well, welcome back. So just like this substitution method, what our goal is when we're solving a system of two equations is we want to obtain a new equation with just one variable. Okay, so keeping that, so here's our first example. We have 4a minus 7b equals 13 and 2a minus 7b equals 3. So go ahead and write that down. Okay. Now, with the addition method, my goal is to be able to add the two equations so that one of the variables eliminates. So what I'm going to do is I'm going to look at the a's. If I add those a's, will one of them eliminate? Well, no, that'll be a 6a. If I add these b's, will one of them eliminate? No, that'd be a negative 14b. So what could I do to make it possible so that one set of my variables would eliminate? Well, I do notice that the 7s, if one of them was a positive 7, then they would. So you know what? Because of the property of equality, I'm going to take the second equation and I'm going to multiply the whole thing by negative. So I'll rewrite the first equation, 4a minus 7b equals 13. Copy it with me. And then it's the opposite of 2a, and then it's plus 7b equals negative 3. Now remember, you have to distribute that negative to each part of the equation. Now can I add these two equations so that one of the variables eliminates? Well, yes, 4 and a negative 2a is 2a, and negative 7b and 7b make a big fat 0. 13 minus 3 is 10. Oh, I'm loving this. So a equals 5. Now we know from the substitution method that we're not done yet. We need to go and find b. Now you can choose whichever equation you want, the first one or the second one, whichever one appears easier to you. I'm going to choose the second one. So 2 times a, 2 times 5, minus 7b is equal to 3. So it's 10 minus 7b equal to 3. Subtract 10 from both sides. So now I'm going to have negative 7b equals negative 7. So then b is equal to 1. So my solution is a equals 5 and b equals 1. Great. Now if you need to, you can pause the video and get this example copied down. Okay, our second problem. We've got a system of equations and we're going to use the addition method. So what I'm going to do is I'm going to look at the two variables and see if they would eliminate as they are. Negative 9y and positive 9y. Loving that. Now 5 and negative 10z, that would not eliminate, but I don't need it to because I already have one pair that does. So let's add them as they are. Negative 9y and 9y is a 0. A 5z and a negative 10z is a negative 5z. 1 and 2 is 3. Now I'm going to get a fraction as the answer, but that's okay, right? Fractions are numbers too. So that is the answer for z. Now I need to substitute this into one of the equations to find y. Well, I notice it's 3/5, and I think I might use the first equation because 5 times 3/5 will reduce, okay? So I have 9y plus 5 times 3/5, which is the value of z, is equal to 1. So we get 9y, the 5's reduce out, plus 3 equals 1. Subtract 3, I get negative 2. So y equals negative 2/9. Voila, I have now solved the second system of equations. Now pause the video if you need to take an extra minute or two to copy it down. Okay, now you can see the problems are getting more challenging. Yikes, Kleiber, what's up with all the fractions? Well, you know, fractions are numbers too. Okay, so addition method, I want one of my variables to eliminate. Now, if I look at them as they are, we notice that the x's, 3/4 and 5/4, that would make an 8/4, so it doesn't reduce. Negative 1/6 and negative 1/6 makes a negative 2/6. However, if I multiply one of the equations by a negative, then I will have opposites. So notice how I'm organizing my work. I would like you to organize your work in the same way, because when we add vertically. Whoops, I made a mistake right there. It's 3/4 x minus 1/6 y is equal to a negative 12. And I notice if I multiply the second equation by a negative, then the y's will cancel out. But I have to distribute the negative to each part of my equation. So my negative 22 becomes a positive 22. Now be careful with adding. It's not that big a deal. 3/4 and a negative 5/4 is a negative 2/4. We'll reduce that in just a bit. Negative 1/6 and 1/6 is a 0. Negative 12 and 22 is 10. Okay? So now if I multiply by the reciprocal, which is a negative 4/2, multiply this by a negative 4/2, and I get x is equal, well, 2 goes into 10 5 times, is equal to negative 20. Well, that worked out nice. Now we're not done. We got to solve for y. So I look at my equations, either the first one or the second one, to substitute 20, negative 20 for x. Well, both of them will be just fine. So I'll just pick the first one. 3/4 times negative 20 minus 1/6 y is equal to negative 12. Well, we know 4 goes into 20 5 times. Oops, I accidentally pressed the stop button. I hope it didn't ruin it. And so now I have negative 15 minus 1/6 y is equal to negative 12. So I add 15, negative 1/6 y is 3, multiplied by the reciprocal, so negative 6, so y equals negative 18. So there is my solution, negative 20, negative 18. So pause the video if you need more time to copy this example down. Okay, our very last problem. Woohoo! Okay, so I notice in this problem I've got the distributive property, and so you know what I'm going to do is I'm going to distribute the quantity to get 4a minus 8b, and that is equal to 8. And then I have 2a plus 8b is equal to negative 8. Remember, it's the addition method, so my goal is to add the variables so that one of them will eliminate. Well, when I look at this, I notice then that the b's will eliminate as it is, so I don't have to do any changing around. So it's going to be 6a equals 0. Wow! So if I divide by 6, a equals 0. Well, that wasn't so bad. Now I pick one of the equations to substitute a in. I'll pick the second one. So 2 times 0 plus 4b is equal to negative 8. So of course 2 times 0 is just 0. 2 times 4b is 8b is equal to negative 8. So therefore b is equal to negative 1. Great. Now you may finish copying down this problem, and then, believe it or not, you can actually start working on your homework problems that are on the side board. So go ahead and do that. Get cracking so you won't have any homework over homecoming week. Have a great weekend. Over homecoming weekend. Have a great weekend. Bye.